Hi, my name is Kimberly Flores, and I'm going to be talking about the history of the atomic theory. There are 6 different atomic models, and the first one that I'm going to be talking about is the Democritus atomic model. So a little background on Democritus is that he was born c. 460 and he died c. 370 BC. He was an ancient Greek philosopher, and he was a wealthy citizen of Abdera. He's known as the laughing philosopher because he was always happy and he believed that the purpose of life was for everyone to be happy. So Democritus's theory was that if you take a piece of matter and you break that in half, and then you break that in half again, and that in half again, and so forth, you'll get to a small piece that is unbreakable. So around 400 BC, he conducted an experiment with a seashell, and he broke it in half, and then broke that piece in half, and that piece in half, and then eventually he had a small powder, and he took the smallest piece of that powder, and that is what he named atomos, which means uncuttable in Greek, and now we know it as the atom. Unfortunately, his theory was dismissed because Aristotle did not believe that that could happen, and he was like a well-known scientist, so whatever he thought is what the people thought. So this is the atom that Democritus discovered, but there aren't any subatomic particles yet because the protons and neutrons and electrons have yet to be discovered, but this is only the first of the 6 models, so later on more scientists will discover them. So the second atomic model that I'm going to be talking about was discovered by John Dalton. So some background on John Dalton was that he was born 1776 and he died 1844, and he was born in Eaglesfield, England, and he was colorblind and from a poor family, and when he was 12 years old he was a teacher, and then eventually he became a math and philosophy tutor. In 1803, Dalton did many experiments on gases, and he found out that in a mixture of non-reacting gases, the total pressure exerted is equal to the sum of the partial pressures of the individual gases, and that's known as Dalton's law of partial pressure. Dalton thought that the law of conservation of mass and the law of definite proportions could be used to explain the idea of atoms, and he thought that everything was composed of atoms, and he thought that they were solid, massy, and movable particles. So Dalton didn't have the necessary equipment to see if atoms had any internal structure, so this is what he thought an atom looked like. His atomic theory is known as the billiard ball model. Because of Dalton's experiments on gases and his research on compounds, his atomic theory is that matter is composed of atoms. Atoms are indivisible and indestructible. Atoms of the same element are identical in mass, size, and other chemical properties. Atoms of a specific element are different from those of another element, and different atoms combined in simple whole number ratios to form compounds. And in a chemical reaction, atoms are separated, combined, or rearranged. So the third atomic model that I'm going to be talking about was discovered by Joseph John, or J.J. Thomson. So a little background on J.J. Thomson is that he was born in 1856 and he died in 1940. He was from Cheetham Hill, England, and he received a scholarship and attended Trinity College. And by the age of 28, he was the Cavendish Professor of Physics. So Thomson experimented with cathode ray tubes, and cathode ray tubes are sealed glass tubes, but most of the air has been evacuated. And a high voltage was applied across 2 electrodes from the tubes, and it went from the cathode, or the negatively charged particles, to the anode, the positively charged particles. So Thomson placed 2 oppositely charged electric plates around the cathode ray, and the cathode ray went away from the negatively charged particles and towards the positively charged particles, so that indicated that the cathode ray was made up of negatively charged particles. And the results of the experiment helped Thomson determine the mass-to-charge ratio of the cathode ray particles because they were smaller than an atom. The results of Thomson's experiment helped him determine the mass-to-charge ratio of the cathode ray particles because the particles were smaller than any known atom. He repeated his experiment using different metals, and the results were the same no matter what. So from the evidence, he made the conclusions that the cathode ray is composed of negatively charged particles, or electrons, and the particles are a part of an atom because the mass is only about 1/2000th of the mass of a hydrogen atom, and the subatomic particles are found within atoms of all elements. He called his model the plum-pudding model because he thought that the inside of the atom was a soup-like, and it's the positively charged matter, and the smaller particles are the negatively charged particles, or the electrons. So the fourth atomic model that was created by Ernest Rutherford. And a little background on him is that he was born in 1871 and he died in 1937. He was born in Spring Grove, New Zealand, and in 1887 he received a scholarship from Nelson Collegiate, and in 1990 he received another scholarship at Kimberly. So Rutherford's experiment was called the gold foil experiment because he fired a thin beam of alpha particles to a thin sheet of pure gold. And because of Thomson's plum pudding model, he thought that most of the alpha particles would go straight through the gold foil, and he was right. Almost all of them did, but 1 in 20,000 deflected greater than 90 degrees. And because most of them went through the gold foil, he found out that the atom contains mostly empty space. But the results of his experiment were that he found out the atom has a positively charged nucleus, and he called his model the nuclear model because he found out that the atom has a positively charged nucleus, and this is what his atomic model looks like. So the fifth atomic model that I'm going to be talking about is Niels Bohr's atomic model. So a little background on Bohr is that he was born in 1885 and he died in 1962. He was born in Copenhagen, Denmark, and he attended Copenhagen University, where he got his master's and doctorate in physics in 1911. After that, he worked in the Cavendish Laboratory with J.J. Thomson. So in 1913, he did his experiment and he modified Rutherford's model by requiring that the electrons move in orbits of fixed size and energy. He found that the energy depends on the size of the orbit, and radiation occurs when an electron jumps from one orbit to another. He used Planck's constant and formulated a formula for the energy levels of the hydrogen atoms. So this is his atomic model, and it's called the planetary model because from his experiment, he found out that electrons orbit the nucleus in electron shells, and that electrons can jump between orbits. So this is his model, and it has the different energy levels and electron orbits that the electrons are on. So the last atomic model that I'm going to be talking about is Erwin Schrödinger's atomic model. So a little background on Schrödinger is that he was born in 1887 and he died in 1961. He was born in Vienna, Austria, and in 1910 he got his PhD in physics at the University of Vienna. After that, in 1914, he was drafted in World War I. So in 1926, he performed his experiment and it disproved Bohr's atomic model. And he used mathematical equations to find the likelihood of finding an electron in a certain position. He found out that the behavior of the electrons could be explained by treating them mathematically as matter waves. From his experiment, he found out that his atomic model does not define the exact path of an electron, but it predicts the odds of the location of the electron. He found out that the electron was a 3D waveform circling the nucleus in a whole number of wavelengths. So this is what Erwin Schrödinger's atomic model looks like, and it is referred to as many different things. It's called the wave model, the electron cloud model, or the quantum mechanical model. And this is what it looks like. At this time, all the subatomic particles were discovered, so it has the nucleus with the protons and the neutrons and the electrons, and we don't know exactly where they are, but we can predict where they are located.